Hello, Hedera community. It is bright and early on a Monday morning. So we will give folks a little bit of time to hop in and get started. We wanted to make sure that we could do a town hall this month with a bunch of different schedules and people being out of the office. So we appreciate you all joining us on an early morning here.
And for some of you, it's late at night, and some of you, it's other times. Thank you for joining us wherever it is for you.
Yes, hopefully it's a good time for a better time for some people. We do try to change up the times on these every once in a while. All right, Sydney, Australia.
Hello, Sydney.
Hello.
I visited Australia for a week, really enjoyed it.
Yes.
It was a very cool place.
I visited Australia right before COVID shut everything down, but they were having all of the wildfires there. So we had ordered a box of these things called N95 masks to bring with us to Australia. And we wore them for about one day during the fires. And then the rest of the time it was quite lovely. So we left the box of N95 masks with my brother and his family in Australia.
Because you won't need those again.
No.
Oh, a term no one knew about that back then.
That's
hello
right.
from Ireland. Hello from Vietnam.
Yes. Hopefully we have I'm trying to figure out what time it is in all these places, but I think it's a more sane hour for some folks. So that's really nice.
Yes. Manila. And Montreal. A little bit closer to here.
All right. Well, we are a couple minutes past the top of the hour, so why don't we go ahead and get started. Lots of questions, some that just for those who, if you're joining for the first time, first of all, welcome and thank you for joining us. Second of all, we do solicit the questions beforehand, and then we try to go through them and make sure that we don't have repeats or things that we've answered before or anything that can be easily found on our FAQ or our website. So just a little preview in terms of how we go about the questions. I think we've got some really interesting ones this month. So Leemon, I will go ahead and start. The first one is for you. Can you elaborate a little bit on the mirror node roadmap? Is the current system of buckets that mirror node operators pay to access the way that you would like to run it in the future, or do you envision a different setup?
Oh, both. We'll keep this way and a new way. So let's talk about mirror nodes. Right now, what we have are mirror nodes. Both Hedera runs one, and also the community are running a bunch of mirror nodes. And they watch everything that's happening on the network and they'll answer questions for you. You could also imagine someone who just wants to run a mirror node for their own private use, and they wouldn't open it up to the world, they would just run their own. All of this is possible. The way it works right now is that the network, every node on the network uploads what's going on to a server, just a bunch of files to a server, and then anyone in the world can download those from the server. And if you run a mirror node software is free, you can download the software, and then it can be set up so that it's constantly going to that server and downloading those files. If you want to, you can do that. Alternatively, what you can do in the future is run the other kind of mirror node, and we will build that as well. And so what that will be is a computer that is acting almost like a MainNet node. It's doing not consensus, but it's doing all of the processing of the transactions, and it's internally doing consensus. It's not voting in the consensus, but it's reproducing, recalculating the consensus. So if you imagine you have the MainNet where they're all talking to each other and gossiping, they gossip these events, the little blocks of transactions, and then each one, when it builds up a pile of events, can calculate what the consensus is, and then it can process all the transactions in order to update the state. The mirror nodes will form their own network and gossip with each other. And the MainNet nodes will occasionally send an event to a mirror node. And that's it, one-way traffic. So the mirror nodes aren't talking to the MainNet is talking to the mirror nodes. And then the mirror nodes are gossiping among themselves, so everyone gets all the events. They can't manipulate them because the events are digitally signed by the MainNet nodes. So the mirror nodes are an entirely separate network in a real sense. They can't hurt the mainnet. They can gossip them, they can all find out what they are, and then they do the exact same thing the mainnet does, using the exact same code. And so when you build up a pile of these events, you now can calculate the consensus locally. You can figure out all the transactions in the right order, and then you can process them and update the state. And the mirror nodes can do the same thing the mainnet nodes do. They just have a state that's evolving in time. And the states have digital signatures on them from the mainnet. And so one mirror node could give another mirror node the state when it joins. And so it'll act very much like the mainnet. The code for it will be very much like the mainnet code. It'll just be a tweak to the mainnet code where you have a flag that says, I'm a mirror node. It will mean that you have to do as much computation and have the bandwidth of a mainnet node. So maybe you wouldn't want to do that. But it means that you'll have lower latency. You don't have to wait for the file to go off to that server and come back down. You kind of get it immediately. And you also will be knowing for sure that the code you think the mainnet is running, it really is running, because you'll watch the state evolving over time. And if you got out of sync, then you would know it. I mean, you'd actually instantly, they would tell you there'd be an error message if you ever got out of sync. And so this new kind of mirror node will be able to give you all those benefits. So that's something we'll do. I think that there's interest in that, but I also think that there's a lot of people that are interested in continuing to run the current kind of mirror node. And so we'll have both.
All right, thanks, Leemon. Okay, the next one, Leemon, is on fees. So Hedera's fee schedule must be low enough to allow Hedera to scale and high enough to incentivize nodes to put forth stake. Can you speak to how this balance is reached and the various factors considered when setting the fee schedule? This person notes that there's concern around among the community that the low fees will result in node staking rewards being too low to act as an incentive and jeopardize the ability to scale. They do note that they personally have full confidence in Hedera, and I will probably note Leemon's ability to do the math here.
Math is fun. So yeah, so what we have done is we have built a network that is incredibly fast. We can do 10,000 a second. That's what it's throttled to right now. We'll allow it to go much faster in the future. Because it is fast, we can afford to make the prices very low when we get a lot of traffic. And so in order to make it self-sustaining, being able to pay all the nodes to run, you have to have enough fees flowing in to support all those nodes, which is fine if you can do lots of transactions per second. If you're getting lots of transactions per second, then you can afford to make each transaction 1/100th of a cent. Or for token transfers, it's 1/10 of a cent. This is good. And so we right now are already the most used ledger. We're doing more transactions per second than any other ledger. We've done 1.4 billion transactions, real ones, not test transactions, 1.4 billion transactions. That's more than Ethereum or Bitcoin put together, but we did it in a year and a half, and we're ramping up. We have a number of people in the pipeline saying that they plan to use us for a lot. So it was exciting when in a year and a half, we reached the milestone of having done 1 billion transactions. But we're being told by our partners that we're going to be doing 1 billion a month, and then many billion a month. We're actually on a trajectory to be doing quite a few. And so I'm not worried about becoming self-sustaining from the transaction fees. We don't have to charge $1 million per transaction because we're going to have a lot of transactions and we can handle a lot of transactions. And then at 1/100th of a cent each, it really does support lots of nodes and lots of employees and lots of things. It really is pretty massive. And that's at 1/100th of a cent a piece. If it's all tokens, then it's 1/10 of a cent a piece. And so then it's even better. You get 10 times as much fees at a given traffic level. So yes, we're constantly monitoring all of this. And I talked about the traffic level. The performance here is important. We are right now throttled to 10,000 transactions a second. I think it will rise to that. And when it does, well, then we'll make it 20,000, or maybe we'll raise the limit before then. I don't know. We're not putting a whole lot of effort into worrying about that right now. But as we get closer to 10,000, we'll do that. And we do keep a goal of keeping the network fast. So right now we've throttled it down to 10,000. And if we ever add a feature and just as a side effect, it screws up the timing so we can no longer reach 10,000, then what we do is we put some effort into tweaking it and getting it back up to 10,000. We make sure that we stay there. Same thing on the latency. The latency changes over time, as we're adding features and things. And we've been told by exchanges that they really want end-to-end to be under 10 seconds. So end-to-end isn't just the time for the consensus, but it's also the time for it to go off, those files to go off to that server and then come down to the mirror node, and then for the mirror node to process them and be able to show them to users. We want that whole end-to-end to be under 10 seconds. And so that's what we do. If it goes up, it's not a big deal, but as it gets close to that, then we do some tweaks, and then it comes back down. You'll see latency going down in the very near future as we change some settings, because it's getting close to that limit, so we want it to go back down again. So we just are constantly making sure that we stay within these limits of the 10,000 and the 10 seconds, but we have lots of ideas for going way beyond 10,000 and way below 10 seconds, but we're just not a high priority right now. As long as everybody's happy, then we're not putting a priority on that. We're putting a priority on building new features and that sort of thing. So that's how it all works out.
Let me just add, Leemon, implicit, or at least what I read into the question, was maybe a misunderstanding of how we determine what staking rewards are that we would pay. That there is an assumption that staking rewards are a percentage of transaction fees or something like that.
Yeah, you're probably right. Let me address that. They're not. There are staking rewards and there are fees, and they are two different numbers that the governing council governs by setting these numbers. And so the governing council decides how much a node is being paid to be a node, and the governing council is deciding how much you charge for the transactions. And at the moment, when our number of transactions per second is lower, then those two numbers may not match. So we're paying the nodes more than they're coming in as transaction fees. And there's an enormous treasury, and so we could do this for years. I don't think we'll have to do this for years. The trajectory is that we will probably be able to be self-sustaining faster than that. But it is not just that the nodes get paid a fraction of the transaction fees. They're being paid from treasury, and there's a big treasury, and we can pay them a lot before we run out of treasury. And so the idea is that it would become self-sustaining in the future, and at the moment we've got a long runway. So thanks, Mance. You're probably right. I think there's a lot of misconception that somehow a fraction of each transaction fee is going to pay all the nodes, and that's not true. There is a little fraction that goes to that one node that you transmitted through because it did specific work just for your transaction. So yes, a fraction of it does go to that one node. But other than that, no, the two numbers are unrelated.
Right. Thanks both. I will note that, we get these questions written, so sometimes we have to do a little bit of interpretation. So if you ever feel like you want something very specifically addressed, please do note that. Mance, this next one is for you, also related to HBAR, and I think the questioner must be somewhere from the South because they ask, more HBAR tokens have been released this year than what was stated in the latest roadmap. Are y'all planning to publish a new roadmap with new token release numbers?
Yes. And I know the vernacular well. So I don't know if the community knows this, but I grew up in rural Mississippi, in a town literally of 1,500 people, and graduated from this tiny little high school of 45, class of 45. So I certainly appreciate the vernacular there. We are, our chief compliance officer, Sam Brilski, has been working on this document for some time, for months, believe it or not. It's complicated. It's complicated in the trying to provide as much transparency and clarity around the tokens, not only what the schedule is, but what's been released and how to characterize them. It's not nearly as straightforward as you would think. It's simply not the case that you can say some are in circulating supply and others aren't. I mean, you can draw a very clear line, but if you do that without any nuance, then it's very difficult to understand the truth of the matter, the reality of the situation. So Sam has been working for a long time on a set of definitions that would go into this new document that would provide even additional clarity over what the previous document has. The council is involved in this discussion. CoinCom is involved in reviewing the definitions and helping to understand where to draw those lines. And the document has been written, so we're in the final stages of being able to release that. But yes, I know the community needs it and wants it, and it's imminent. I don't know exactly when, but it's imminent.
Thanks, Mance. And to use another phrase, bless his heart, Sam has been working day and night on that one.
Yes, coming from an Atlanta girl, right?
That's
So
right. When we talk about the community, I'm going to refer to you guys as all y'all.
So I didn't grow up in those states, but I did spend a part of my life in Pittsburgh. And in Pittsburgh, they do not say y'all, they say yuns.
Ah.
Or yuns guys.
Yeah.
At least back when I was there. So you can say y'all to us, or you could say yuns guys to us.
All right. For next set of questions, if anyone's from the Pittsburgh region, please note that in your vernacular. All right, Leemon, how are new nodes bootstrapped onto the mainnet with the latest ledger state if the state changes occur too rapidly, as is the case when the network is operating at peak throughput?
Oh no, they can reconnect at 10,000. It's not a problem. This is cool. So let's talk about this. So the way it works is that once every round, which is about once a second, there is a new state. So we have all this, we have the current state, it's constantly changing, but once around, you could say we take a snapshot of it. And it's a Merkle tree. And so every node then figures out all the hashes up this Merkle tree, and they figure out the hash of the entire state, and they digitally sign it, and they send the signatures out to everybody else. So within a second or so of it ending, all the nodes have the state, and they have digital signatures on that state. If a node is trying to reconnect, then it can ask any of the nodes, and they can say, okay, here's the state, and hand it the state. Now, the state will someday grow to terabytes. So it could hand it all those terabytes, which would take a long time. That's okay, it's not a problem. By that point, of course, you're so far behind that you have to do it again. So now you go to someone else and you say, wow, I'm an hour behind. Could you give me the state? And he says, sure, I'll give you the state. But you're not starting from scratch. You have the current state, which is a Merkle tree. A Merkle tree is a tree where you have hashes in it. But because of those hashes, if you have a Merkle tree and I have a Merkle tree, you could say you have the root of your tree has 2 children, the root of my tree has 2 children. You could say, well, here's my 2 children. The teacher, there's a teacher and a learner. The teacher says, here's my 2 children, and one of them has this hash and the other one has this hash. And then the learner says, oh, wait, I have 2 children. One of them has a hash that matches, but the other one has a different hash. That means for the one that hashes, an entire half of your entire state is identical to an entire hash of the teacher's state. So there's no need to send it. And so what you end up doing is walking down the 2 trees and you end up just sending the diff. It's like rsync. And there's all sorts of clever things that are done to make it fast over a long, slow connection, long ping time, slow connection. And so what ends up happening is that maybe you join and it takes an hour for you to download a multi-terabyte state someday. Okay, then you join again. Well, then it only takes you a half hour to download what you missed. Well, then you join again, it only takes you 15 minutes to download what you missed while you were doing the second download. Because each download is less, so each download is faster. So each download involves you waiting and missing less. You're taking less time to do it, so you've missed less. And so then eventually you get to the point where you say, oh, now I'm up to date. Does this work? Yes. Does it even work when we're doing 10,000 transactions per second? Yes, we test that all the time. Even at 10,000 transactions per second, you get caught up. And usually it happens in just a single sync. Sometimes you have to do a couple of syncs, but you definitely get caught up. And even when our state is multi-terabytes, if we're doing 10,000 a second, you will absolutely be able to get caught up. And so this happens when the network's not waiting for you, it just happens. So yes, even at speed, and even when our state is many orders of magnitude bigger than it is now, we will still be able to do this.
All right. Thanks, Leemon. Okay, we have another HBAR question. Are the undistributed coins technically minted and active For example, only 1/3 of the coins will have been distributed by 2025, meaning that Hedera still sits on 2/3 of all the coins, but 31% could be used to take control of the network. In other words, does that directly mean that Hedera has power to control voting and consensus itself?
So that was a long question. So right now, the consensus algorithm is such that it is asynchronous Byzantine fault tolerant, guaranteed to be secure if less than 1/3 are malicious, or less than 1/3 of the weight is malicious. So it is the case that if somebody has 1/3 of the weight, they can be malicious and they can do bad things to the network. So we never want to have one having more than 1/3 of the weight. Now, right now, the council has all the coins, or a lot of coins. And of course, you could say the council could be malicious. Well, sure, but the council also controls the code base. So it could be malicious by changing the code base. I mean, I'm not worried about that. What you don't have, though, is a single council member controlling any of those coins at all. And so no single council member can corrupt the network. And that's what you have to worry about. So the way this works is the treasury is this enormous amount of coins, but it isn't like we break it up into each council member getting 1/39 of it. And even when it's staked to a node, it isn't like the owner of that node actually gets 1/39 of all the treasury and could do whatever they want with it. It doesn't work like that. The treasury coins are controlled by the vote of the council as a whole. And so the whole council has to have a majority vote in order to change where the coins are being proxied and where they're being used and to transfer them, all those things. So while Hedera has all the coins, it is secure because no single rogue council member can do anything with them. And the council as a whole is the governing council. I mean, we should be able to trust them to not stake to a malicious node, stake all the coins to one node, because if they were that malicious, they could just change the code, and they have control of it. But what we have done is we've set up the checks and balances so they control each other. And so I think that we are secure.
Can I add one? I'm going to add some more to that. I think there's a common misunderstanding, and Leemon, I'll let you describe this in more detail, that the only way you protect the network is by at least in the short term, is by preventing 1/3 of the tokens moving into supply. When in fact, there are two mechanisms, that and not allowing anonymous nodes. You want to comment?
Yeah. So I think this probably is a misunderstanding that's common. Even if all of the coins are dumped into the market today, and a malicious person can get, 99% of all the coins is held by a single malicious person. Well, that doesn't affect us if we have permission nodes. So the way the permission nodes work is that we only allow nodes to join that we trust. And there's a cap on how many HBARs can be sent to each node. It can be proxied to each node, how much weight it can have. And so even if one person has all the coins, you can just make low caps, and what little coins remain, we can distribute to the other nodes, and we're fine. So this is important. There is no security flaw, even if all the coins are distributed and 99% to go to a malicious person while it's permissioned. But we have this path of going towards non-permission. So we start with the council running nodes, and then we go to trusted parties from the community running nodes, and then we go to less trusted parties running nodes, and then we go to anonymous people running nodes. Really, you only care about the coins when you get to that last step of the anonymous people running nodes. And so that's what we care about. And we don't have any problem with having all the coins in the market as long as there's reasons to believe that they're spread out. And this is true for every ledger that's proof of stake. Any ledger that's proof of stake, if one person could get all of the stake in the world, then of course they could do bad things. But if it's well spread out, like most cryptocurrencies are, and I think even the coins that have been released for Hedera are well spread out, then you don't have to worry that one person has 1/3 of the coins and they can launch an attack. And every proof of stake system works on this principle. And so when we get to the time that we are doing anonymous nodes, we will look at what has been released. And I assume it'll be more than 1/3, maybe not, maybe less than 1/3. But even if it were all the coins, we would just look at how they're spread out. And if we said, you know what? We realize that this one person over here has 90% of the coins in the world, or a third of the coins in the world. Then we wouldn't do anonymous nodes. We just wouldn't do it. So it'd be secure forever. But more likely, we're going to see the same thing we see now, the same thing we see with every cryptocurrency, the same thing you see with gold or real estate, is that it's a big world. The stuff gets spread out. And if one person wanted to corner the market, they'd have to buy really fast, which would then drive up the price and make it impossible for them to corner the market. If you wanted to buy a third of all the gold on the planet, you just couldn't. It would just be too hard. First of all, it would cost too much, but also the very act of trying to buy it would make the price skyrocket. So I am optimistic that proof of stake works well for any ledger that does it, and that it will work well for us. But if it doesn't, then we won't have anonymous nodes. But I see no reason to think we won't be able to do anonymous nodes when that time comes.
All right, thanks to you both. Mance, one of the more recent council members to join Hedera is Shinhan Bank. Are you worried at all about Shinhan joining, I don't know how to pronounce this, but I think it's Klatyn, which is South Korea's public blockchain?
No, not at all. In fact, I would anticipate that most of our council members end up participating in some way with at least one other layer one network to some degree. So when the market matures and the biggest and most important use cases are fully deployed, let me restate it. Let me say it a different way. Any company that is going to launch a product on one of these layer ones that requires the best in terms of security and availability, et cetera, it's very likely that they launch on more than one layer one. They'll be multi-platformed. Now, it won't start that way. It's not likely to start that way. But at maturity, it's probably the case, assuming that we're talking about tokens are involved in some way. That it's a CBDC or stablecoin or you name it. If there are tokens associated with the product or service that's being offered, it's very likely that it's going to be a multi-platform deployment at maturity. And so I think there'll be a handful of layer one platforms that are here for the next 100 years. I fully expect that Hedera is going to be one of those. As you all have heard many times, we're here to build a company that's around for 100 years, a 100-year company. But I also expect that the most widely scaled and widely used solutions will be multi-platformed in the end. May not happen in the next year or two or three, but in the end, that will be the case.
All right, thanks, Mance. Leemon, are HBAR network fees pegged to the dollar permanently? If something were to happen to the US dollar, could HBAR be pegged to a different currency?
Oh yeah, so it's easy to switch. So the way it works is that every transaction has a cost in HBARs, but for predictability, we say, here's the cost in US dollars, and then we constantly convert that to HBARs. So once an hour it changes. This allows people to build on top of us because they can predict what the price is. If we told you what the price is in HBARs and kept that fixed, then your real cost would be fluctuating wildly. So what we do is we give you your cost. You can plan your business based on top of us in dollars. And then the HBARs adjust themselves once an hour. And the way they do it is it goes out to a bunch of exchanges, sees what is the conversion between HBARs and dollars on those exchanges, and then does it based on that. If the US dollar were to experience something like hyperinflation, 100% inflation per month, if it were to just crash the way some countries have seen their currencies crash, which I don't anticipate tomorrow, but if that were to happen, then we could switch to the euro or the yuan or whatever. Or we could even switch to a stable coin as our standard. It doesn't matter. We can easily change, the line of code in our computer that goes out into the exchanges And instead of looking at how HBAR compares to dollars, you look at how it compares to something else. And then you're done. It's very easy to switch to something else. At the moment, the US dollar is very stable. It's the world's reserve currency. And so I'm happy with that. But, you know, it could change in the future. Maybe tokenizing gold will be so popular, we'll start pegging it to gold instead. I don't know. There's lots of different options. But the US dollar works just fine for now, and it's really easy to change it if we ever need to. And I should also say that I've been multitasking. Somebody put a link into the chat, and I went there. That looks really cool. That page says we're around 80 TPS right now, which is just kind of neat, and says 1.4 billion transactions handled. Wow, it's like McDonald's. How many million hamburgers served? You know, they used to do that. They don't do that anymore. Now they just say millions and millions served. I thought it was kind of cool. They had a counter. Anyway, we have a counter here. So that's really cool. Apparently built by Mr. Leemon Baird. Leemon Baird, it sounds vaguely familiar. I'm not sure what it reminds me of, but it reminds me of something. Anyway, so thanks.
All right, long lost relatives. Thank you. Mance, after a council member's term has ended, do they sell their 2.5% of total HBARs to the next council member or give them to them? How does this work?
Yeah, so that's a misunderstanding as well. It's not the case that the council members today own Treasury, own the Hedera Treasury. They are council members. I mean, they are legal members of the LLC, but the LLC has been set up so that, in fact, they can't be given Treasury. It's set up so that we, as a council, it's not legal, if you want to think of it in those terms, to vote to give all the council members all of Treasury if they wanted to do so. They don't own Treasury. They do vote the weight of Treasury. And so the tokens that are sitting in Treasury that that have not been released, there's some value, voting weight associated with those. And today, it's the case that we're just giving them their pro rata share of the voting weight for the transactions. When they leave, they don't have the tokens in the first place, so they don't have to transfer them. Whomever else is coming in would be given the pro rata weight of the tokens that are sitting in Treasury to vote. Now, the one caveat is that they are all running nodes, and there are tokens that are earned for running nodes. So anything that they earn that they're holding in tokens, of course, they would take those tokens with them. They earn them. But it's not the case that they have 2.5% of the tokens that they own today. They only own it in the sense that they're part of Hedera, but they don't own it individually.
All right. Thank you, Mance, for clarifying. Leemon, the next one. Data layout is often a factor in computation performance due to things like CPU caches, I/O latency, GPU buses, etc. It looks like Hashgraph node logic layout may be exploitable for reducing work through batching. Do you anticipate Hedera being used in real-time systems to a degree that requires these kind of optimizations? Or does the consensus algorithm and overall system latency preclude physical layout and other architectural details from ever being a bottleneck?
Oh, I love these technical questions. Okay, so you're talking about things like cache effects. We spend a lot of time thinking about all sorts of different things that affect the speed of the system. And so when you're storing things in memory, if you store everything close together, it's better than having it randomly spread out. And if you can access things that are next to each other, it ends up being faster than if you're accessing things spread out. There's all sorts of things like this. You mentioned GPU buses. We're currently not even using the GPU, but we have code that is just amazingly fast. If we need to, we can do our verification on the GPU, and then the GPU bus matters. We spend a lot of time thinking about optimization. And we actually have a huge list of optimizations we haven't even implemented yet, because we don't need to. You know, I mentioned earlier, we want to make sure we're staying at 10,000. We want to make sure that we're staying under the 10 seconds, including the mirror nodes. But other than that, what we're trying to do is get really good features out. And there's a bunch of features we keep adding. Like this year, we added the token service, and we added scheduled transactions. Actually, we added the first half of scheduled transactions. There's a second half coming that's even better, where you can schedule them arbitrarily far in the future. That comes with entity expiration. The two come together. They use the same data structures. So we have been putting a lot of effort into some of these features. For the making things efficient and fast, we do put effort into that. We make a list of things to change, and we change enough of them so that we stay as fast as we are now. And then occasionally we make changes that even make it faster. And we will continue to be doing that. Do I think real-time systems matter? Yes, I do think so. And I think all of the optimizations we look at, which include all the sorts of things on the list that were in the question, are important. And there is a huge list of things that we can do to make things faster. We are not going to forever be at the snail's pace of only 10,000 per second. We do not expect that at all. We expect to be able to go way, way faster. But we don't care right now. Right? We have to prioritize. We care, but we have to prioritize. And so we're always prioritizing things. And so yes, we look at things like data locality and other things, and we sometimes put it on the list, and sometimes we fix it, or we improve it, or we make tweaks that make it faster. And I always love this. And just this morning, I was getting Slacks about tweaks that are making things faster. Little tweaks that make it much faster. I love that kind of thing. So I love all these technical questions today. This is fun.
Fantastic. And now I have in my mind an image of Turbo, who is a cartoon snail who gets super speed powers.
Yes, that's us, Turbo the snail, a mere 10,000 per second.
All right, Leemon, this is probably a bit related. Is the timeline for implementing sharding, staking, community nodes, and anonymous permissionless nodes dependent on network traffic, or is it independent of some of these things?
It's dependent on network traffic and a million other things. So our feature list and our roadmap is all the good ideas that we are going to implement. But sometimes a new good idea comes up that we just really want to implement soon. So we implement it and push everything else. Or sometimes we say some of those things are really needed, but not right now, not because of our current traffic or not because of current aspects. And so it becomes less prioritized, and it will happen in the future, but it's not urgent right now. And so the timeline, the roadmap, is constantly being reprioritized, reorganized. Things get pushed out as new things get inserted now. Things get reordered as priorities change. The traffic on the network is a big part of all of that. So, if tomorrow we went up to 10,000 a second usage on the network, then I'll tell you what, we would put a big priority on immediately going up to 20,000. And we would postpone features if we needed to do that, because we don't want our traffic to equal our limit. We want our traffic to be, well under half our limit. And so if the traffic went up, if the traffic went up over 5,000, we would very quickly go up to 20,000. We would want to do that quickly. So it's all a matter of priorities. We have been rolling out lots of different things, and I love the community's involvement with the HIP process. So things like token fees, where you charge fees in tokens. I love that. I see all this traffic going on that right now. And the community is really involved in this. So you can create a token, and then when people transfer your token, they pay you a fee for it. It's really cool. So there's just lots of things going on right now. And you'll see the roadmap continuing to change and evolve as the governing council governs and decides what order things should be done in. It's just exciting to watch it all.
Thanks, Leemon. And I will note as a quick aside, there is a podcast out today from Beyond the Uniform. I think we'll post it on our social channels, but it talks, there's some great insights in there into some of our decision-making processes and some of the thought behind that. That's just a little bit more macro. So if anyone wants to listen to that as well, another great insight into sort of the processes and the kinds of things that we think about when making decisions here at Hedera. Okay, I get to take the next one. Now armed with great information about Hedera's decentralization, how would you recommend the community help spread the message and info that has been outlined and shared? And, I think the beauty of this is we do have a great decentralized community, and we have, we try to share the information, and then we ask that, if you are up for it, share it in the organic ways that you are most comfortable. So some people love to share on social networks. Other people, as we start to get back to in-person meetings, like to have those conversations. Your local networks, we talk about the fact that, for example, on LinkedIn, it's not always necessarily the first person set of networks and contacts that makes the biggest impact. A lot of times it's that second layer of network. So they have shown that people get more jobs and more referrals and more business from that second layer of networks that you may not even be thinking about, but that you have. So your friends who are then sharing it with their friends, or, you know, those algorithms are automatically sharing it with their friends. So I think those are some of the great ways, you know, as we start to emerge and in-person events get back, get back to, if not what they were, but somewhat reimagined. Those are also great ways to engage your local community and the people who might be most interested in your schools, in your work events, and in your other communities. And we're always happy to help participate in those. If you'd like a guest speaker, you can reach out to pr@hedera.com. Some of those obviously will still be virtual, but we love to share, we love to educate, and we really appreciate everything that you all do to help us do that. Okay, Leemon, another one for you. Currently, the open review source code published in GitHub is not synchronized with the source code used in the Hedera MainNet. For the sake of transparency, it would be more than desirable for these two to be demonstrably the same at all times. Is this possible, and is it planned?
Oh yeah, it's there now. So they're in sync right now. I imagine this is probably an old question that got pushed from a previous month because we don't get time to do all the questions. But yeah, so at the start of this month, we released an update to the released code, and it matches exactly what is running on MainNet right now. And further, we modified our processes. So every month, on the first Thursday of the month, when we upgrade the MainNet with new compiled code, that day or maybe the next day, the source code will be released and will exactly match it. And that's for the bottom layer. For the layers above it, you actually see the source code continuously being modified. And so you're just watching it change. But for the bottom layer, what you see is the source code will be released. And so what's running on MainNet will always match the source code. And so then you can read it and you can see it being changed every month. You can see what changed. In addition, when you have that new kind of mirror node that I talked about, the full mirror nodes, the new kind of mirror node, that will even allow you to run your own mirror node, and that will give you a cryptographic check that MainNet really is running the node, the software that your source code says. Because if it isn't, you will say signatures don't match, and so you will have cryptographic proof that the code is real. And so when we do that, you'll have that.
All right, great, thank you. And another one for you, Leemon, would Hashgraph break down if the network nodes with an aggregate of more than a third of the total HBAR stake were prevented from communicating with the rest of the network for an extended period of time? Or would it continue to work, and would there be any effect on the security of the network?
No. Any ledger has to freeze when you partition it. If it doesn't freeze, then the people in the different partitions could start coming to different conclusions, and you'd end up forking. So it is incredibly important. If there's a ledger that says, hey, if you partition us down the middle and half over here and half over here can't talk to each other, we'll just keep running. Well, then you could do double spins. The two states can get out of sync. It would be a disaster. You could never have finality. If each half is coming to finality on a different conclusion, then it's not really finality. It is incredibly important that for any ledger, if you partition it into two halves, they must freeze. Now, the nice thing about Hedera is that as soon as you have even a slight healing of the partition, just a few messages can get through, you immediately have them making progress. And so even if this partition just deletes almost all the messages but lets some through, both sides will make slow progress. But you have to do it that way. Any ledger has to do that. And I said if it's split down the middle into two halves, the same is true if it's split into thirds. If you think that a third could be malicious, then you could do bad things with firewalls. And so even if it's a full third that is partitioned off, because you don't know who the malicious people are, and because that firewall might be colluding with the malicious people, you want to freeze then too. And this is true for any ledger. There's a simple proof. If you look at the Harvard talk, I think I go through a very easy to understand proof of that. But for any ledger, if a full third is partitioned off, you need to freeze and wait until it's healed. If just under a third is partitioned off though, the big side can just keep going. The little side though needs to freeze and wait until it's healed.
All right, thank you, Leemon. Mance, can you share with us any progress on Toko, which for those who aren't familiar is a project that has been built by DLA Piper for tokenization of assets, and any insights on when we can see tokenized assets in the market via Toko?
Yeah, so in preparation for this call, I did connect with Scott Teal at DLA Piper to get a full update. And the Toko deal pipeline continues to develop with more and more potential deals with an increasing diversity of underlying assets. And it is happening on a truly global scale. The projects that are flowing into their pipeline are coming from around the globe. The projects in the pipeline today include tokenization of mineral deposits, real estate, green bonds or ESG related bonds, energy assets, fine art, collectibles. So it's a broad range of asset types that are being tokenized. It's also the case that asset-backed tokens are, as a deal from a commercial and regulatory perspective and technology perspective, is quite complex. And of course, that's what DLA Piper addresses, is that complexity for the token issuers. But because of that complexity, it's taken a little longer than expected or anticipated. However, the expectation is that in another month or two, some of those commercial deals will be going to market. And so the pipeline continues to grow, the breadth continues to expand, and the issuances are working their way through the process, and they're expecting to be issued. Some of the earlier ones are going to be issued within the next month or two. That's the latest on Toko.
Thanks, Mance. And I do remember talking to Scott and him saying, I think they've spoken with more regulators and lawyers in various different countries. There's a lot of different legal considerations around this. So we are lucky to have such a forward-thinking law firm, not only on the council, but leading this project, because they have probably gone into corners and details that the rest of us can't even imagine.
Yeah.
Okay, Leemon, here's kind of a fun one and also a serious one at the same time. Can you see Hashgraph being applied for critical safety applications, such as, for example, a shutdown system for nuclear power stations that would use multiple independent nodes and redundant sensors in making decisions to shut down before a deadline? In this situation, it appears that lookups would need to occur in near constant time. How would you avoid collisions?
Yes, so this is really good for things like where you need critical security in a nuclear power plant or something, or in a spacecraft. I think the space shuttle had 5 computers that voted on everything. I think it was 3 computers, I don't know. But you can use redundancy and have them voting on things. This is a way of being fault tolerant. So Byzantine fault tolerant is even better than just ordinary fault tolerant, but both are important. And so you can have multiple computers that have reached consensus, and you can have multiple sensors that digitally sign what they're sensing. And then you can let them vote too. So if one sensor is out of sync with the rest of them, you don't believe it. And when I say you don't believe it, I mean your decentralized computers don't believe it. So yeah, it's a great way of doing this. Yeah, how do you avoid collisions? Maybe collusions? I don't know. But yes, if you can ensure that your nodes are controlled by independent people, then you avoid collusion. They could even be off-site. Or you can put them on site, but put them in hardware boxes that you have secure hardware, and you just think that you're not going to have collusion. It's going to be hard to corrupt them. So yeah, I love this. Decentralized is going to work its way into every area of society, and I think this is one of the ways that it will.
All right. Leemon, we talk a lot about Hedera being a 100-year company. How or why are you confident about this when technology advances so quickly? And can a forkless system allow for such longevity?
Yeah, because we're going to advance with it. So we're going to keep updating what we do to match the state of the art. And if somebody builds giant quantum computers someday, we'll change our signature algorithm. It's fun. Watch the NIST. The last NIST contest meeting was, they had a conference. It was really interesting. And so they think they're going to pick some early winners by the end of this year, and we'll have the actual document in a couple of years. So yeah, maybe we'll do that. So things like that. If there's radical changes in the world, we can do it. If we need to use GPUs, we'll use GPUs, and maybe they will radically change. Well, we'll change how we use them. We could even radically change the consensus algorithm if we needed to if we needed to be better. And there's no problems with upgrading. Sometimes you get locked into a legacy technology and you have the innovator's dilemma where it's hard to upgrade. But for us, it's very easy to upgrade. And so we can absolutely upgrade the network to whatever new technologies are necessary. So I'm excited about the future. I can't even imagine what we're going to have 100 years from now. But what I do hope is that we will be around. And if we are, we will absolutely be tracking that and staying on the cutting edge for 100 years.
Awesome. Okay, Mance, what motivates an organization to join the Hedera Governing Council? If the goal of a public company is to maximize profits, how does being on the council help them maximize profits for shareholders?
So it is the case that all the council members run nodes, and the work that they do in processing transactions on those nodes, they're getting paid for. But that's not at all why they join the council, right? That's just a non-issue from their perspective. They do it because they're part of the council, and one of the requirements to be on the council is you have to run the nodes that create the network. The real reason that, pardon me, the real reason that they join, well, it varies from council member to council member. Some council members have products and services that they want to offer the crypto community at large, DLT community at large. And by participating with us, they're expecting that those services will be used by our projects, by other council members, dApps that are in the market that are not related to the council members, et cetera. Some organizations have vertical use cases that they care about and they want to go to market with, and they need an organization like Hedera to exist for them to be able to go to market for all the reasons that, all the value points that are associated with our platform in terms of security and decentralization of governance and consensus and special features that are regulatory friendly, et cetera. They all need those features. They need it to exist. And the fact that they can participate as in the governance is sort of icing on the cake. And it allows them to influence what the product roadmap is or the regulatory posture is, et cetera, et cetera, et cetera. And so they all need that. A lot of the council members joined early on 2 plus years ago, just because they wanted to see how the market was going to unfold. They didn't even have their strategies in place at that point, but they were going to be creating strategies. They knew that. And by participating with us, it gave them the opportunity to figure those strategies out and then begin executing on them and execute on those strategies, not alone, because nearly all of the use cases have some kind of business network related to it. And when I say business network, what I mean is other organizations in an ecosystem that are deriving value from the use case. And so having other council members to collaborate with and work with is part of the draw for council members to participate. So it's just a broad array of different reasons that any given council member might join. And, if we were to poll them today, I think that we would get at least half a dozen major themes of why they're joining. So it's, but they're all here because they have businesses to run and they see value in the work that they're doing with us and that they're going to do in the future related to this distributed ledger space.
Thanks, Mance. Okay, Leemon, can we think of Hedera as an enormous event loop, select statement, that synchronizes all concurrent activities of its participants? So we're all on the same thread.
Sure, you can say that. There's lots of interesting analogies for how it works. And that's a good one.
All right. And then does the Hashgraph algorithm use Lamport or other logical clocks to determine the order of events? Or are the hashes that are stamped on the events the only data used for ordering?
So we do that plus more. So we have every node, when it creates an event, puts in a timestamp from its local clock of what time it thinks, UTC time, of when it thinks it happened. If the clocks are bad, we still reach consensus. It's still somewhat fair. It's still mathematically guaranteed to be ABFT. It's extremely like a Lamport clock or other logical clocks. But you don't really have a timestamp that you could send to a court to say, I did it by noon on Tuesday, if we're just making up random times. For example, you could set your clock to be equal to the generation of the event, and you would get all the benefits that you have from a Lamport clock or whatever, but you wouldn't have the fair timestamps. If you want more fairness and you want better timestamps, then instead of just using the generation as your clock, you use the real clock, as your timestamp. And in that case, you get all of the same benefits of Lamport and other types of clocks, but you get these additional benefits as well. And so that's what we do. That's what Hashgraph does.
Well, okay, Mance, do outside parties need to sign NDAs before they take part in SIGs? And if not, what's to stop them from stealing or swiping ideas discussed at the SIGs?
Yeah. So just a point of clarification, we no longer have SIGs. We now have a consolidated Hedera's user group where the different use cases are talked about within a single user group. So we don't have SIGs anymore, but we do have the HUG, Hedera user group. It's a good point about protecting the IP, pardon me. Of all the presenters, all the presenters that participate in the HUG, the Hedera users group, know the rules ahead of the workshop that they're going to be giving their presentation to. So they understand what they may or may not want to share. They can come to their own conclusions about what they want to share. That means that we work with them to find the right balance, because sometimes they just aren't ready to share their ideas in public. And so they might want to scale them back. That certainly does happen. And we have run other workshops under NDA before. I mean, it is the case that we've tried doing all this under NDA, but we're looking at alternatives like simple opt-in to Chatham House rules, which is being viewed very favorably by the participants in the HUG. So we're experimenting. We're experimenting with finding the right balance between making it possible for everyone in the HUG to get the benefit of the discussion around the use cases, while at the same time protecting IP.
Thanks, Mance. Leemon, can you elaborate on the file service limitations and capabilities? For example, could it be used to host a website and handle DNS for pointing to a domain name, or alternatively host a web portal as part of a developed application?
So we're designed so that we will work even if the DNS system collapses, which is good. You could, of course, store web pages as files, but it's probably cheaper and faster and more convenient to users if they could simply host the website somewhere else and put the hash of the web page into Hedera to prove that it existed at a certain moment. You have to think about, why do you need consensus? Why do you need your site hosted multiple places with guarantees about the world seeing the same thing? So typically what you would do is host the site somewhere else and put a hash on the system. And if you do that, then DNS and everything works. If people really wanted to start putting websites onto Hedera, then we could build bridges for DNS and so on, and the community could build such things. But I don't think there's a huge need for that. So typically what you do is you store your bulk information elsewhere and put a hash of it into our file system. That's the normal usage, but you can do whatever you want.
All right, thanks, Leemon. And we are just before the top of the hour. So Mance, I'm gonna wrap here with a very serious question for you. When will we see a return of the rock star look from a recently surfaced photo? And can Mance grow his hair out again before we hit 39 council members?
Yeah. So look, I did see the photo. It's not real. It's just not real. Looks cool. I like the hair, but I was in the military back then. And I've had short hair, you know, since my high school days. Where anyway, so the interesting thing is I do know who the Gaither vocal band is that's associated with that particular meme, and I actually bought my parents tickets to see the Gaither vocal band in Red Rocks amphitheater out in Denver about 15 years ago. So very cool photo. I can't grow my hair that way anymore. It doesn't work. My hair doesn't work. And but I enjoyed the meme for sure.
All right. Well, thank you so much. Thank you, community. We appreciate you. Everybody, please stay safe and healthy out there. And we will see you again next time. Have a good one.
Thanks.
Bye.